So this is a demo on showing how the motors turn in relation to what command you give it. So just for reference, this is the front of the vehicle, and this is the back. So if I hit forward, reverse, strafe left, strafe right, rotate left, and rotate right. So this is a 3D model mock-up that I made of the Augerbot in Tinkercad, and I did link this to my project overview. The only thing is you'll have to make a Tinkercad account to look at it, I think. But this will give you a good idea of how the parts are assembled, just in case it wasn't obvious from the camera footage that I shown. So you should be able to like take it apart and move all the stuff in it. The only other thing I'll note is that this red block and these two smaller red blocks here are supposed to be the wood that I used for the frame, but everything else is a 3D printed piece. So just to make that explicitly clear. So I'm going to do just a brief overview of the Augerbot and the parts inside of it. So most of these pieces are 3D printed. So the top piece is printed as a single piece, which is a cover. It's got these holes in it for the peg connectors. So there's peg connectors here. These are printed individually. And then there's the base piece. I split it into two pieces to make it easier to print. And it's glued together, also with a small piece of wood on the bottom. So if you can see, right here is a piece of wood, which is a 3x1 that runs the length of the Augerbot. And also there's two wood blocks. So that acts as the support for the bottom of the enclosure for the electronics. That's because these two motor holders are screwed onto the top of the 3x1. And so you need some space off the top. So these right here, they're two pieces, so you can see that this is the other side of the pieces. The motors slide inside, and they are screwed on to the front with two set screws, and that's how they're held in place. And then there's a slot here for the electrical connections here. Then you can see here is the pulley wheels for each auger, which are connected directly to the shafts of the motors, and that's what drives the augers, as you can see. So if you look below, there's 4 auger struts. So these give support to the frame and hold the augers in place. And also in these sections right here, there is a 10 millimeter bearing. It's a 10 millimeter ball bearing. And in the auger itself is a 10 millimeter aluminum rod. So when I inserted the rod through the auger, I heated it up with a torch and then pushed it through to the appropriate length. So the rod goes to the end of this bearing and then up the top, and it sticks out about 3/4 of an inch through the front here. So that way I can put these end cap pieces on. So I can actually take them off, and you can see is the aluminum rod, which is in the inside. So yeah, that's kind of a general overview of how all the Augerbots is assembled. And also I used a lot of very small screws and washers to screw everything together. There's also screws in this section right here. So there's a faceplate that covers the bearing, the 10 millimeter bearing, to keep it in place and keep dirt off, which is, I think, is pretty important. So I'll just do a general overview of the parts. So right here is the ESP32 camera. It's got a cam right on the front of it. So that's where the stream is from. And I also drilled a hole in the front of the case, so that way the camera can see through the case, obviously. And also there's a 3D printed ESP32 mount, which it slides into, and then that's hot glued to the bottom of the base here. This is the Arduino Due. So this is connected to the ESP32 with a serial wire, and that's what sends the commands from the ESP32 to the Arduino Due. And you can see this lots of wires here. These wires control the two L298 H bridges. So each H bridge can control 2 motors, so that's why there's 2 of them. And all these wires are basically just how the Arduino Due reads the speed from the motor and then sets the speed accordingly. And that's what all these wires are for. And these motors have encoders on them, so that way you can read what the actual speed is of them, and that's where the PID control comes into play. Also is a 5-volt voltage regulator, so that's connected directly from the battery, and the output 5 volts is connected to everything here, because everything uses 5 volts at some part. And then also just the direct battery output is connected to the H bridges, because these motors are 12-volt motors, and this is a 12.6-volt battery pack. And then also the last thing is the switch on the end here, so that just turns it on and off. Also the augers, there's 2 different versions of them, so there's the left and there's the right auger. They're exactly the same except for they're mirrored. So when you're setting it up, the auger, so this is the front. You want your auger, so you want this one here and then this one here. So you can see that the spirals on them are actually different. And then on the bottom one, you want it to be the opposite of this one, and then you want this one to be the opposite of this one, if that makes sense. Because obviously if you put them on in the wrong orientation, the code that I provided won't work, and you'll have to adjust the code yourself. But basically, this one's the same as this one, this one's the same as this one. And then that way, you know, if this one spins this way, this one spins this way, then it can kind of like go forward, in theory anyway. So this is how I connect the Android controller app to the Augerbot. So what I do, I open up the app first, and on Android you can, so go to your tab screen. So if you hold your icon, there's an option to open in split screen. And then I will open the settings app. So then I have the controller app here and the settings over here. I go to the Wi-Fi section. So if your Augerbot is on, you should see the network, ESP32 Augerbot. So you want to connect to that. And then once it's connected, you can also drag this over so you have a wider view. So you click refresh view, and now you can see the ESP32cam stream. So this, as you can see, like, it's not very optimized for the width. Like, a lot of the screen's cut off. So what you can do, there's these 2 buttons here. So you can increase the width or decrease the width. So you want to decrease the width until you see black bars, and then that way, you know, you can see the entire screen. Right now, the ESP32 cam is upside down, which is odd because I have another ESP32 cam and it's right side up by default. So I'll probably have to mess around in the settings more of the ESP32 cam to get it to display properly. But for the purposes of this video, it still works fine and you can see what the camera sees. So yeah, the refresh stream, if you ever disconnect, just hit the refresh stream again and you should be able to see the ESP32 cam as long as you're connected. This right here controls the speed, so you can, you know, low speed, high speed, and then you go forward, and you know, you can do whatever. So that's how you connect to the ESP32 cam of the Augerbot. So this is the circuit diagram, and there's also a motor orientation diagram here too. So I'll just start with this first because it's pretty simple. So it shows where the motors are in relation to the front of the vehicle. So this is motor 1, motor 2, motor 3, motor 4. So this is just for the purposes of the software to designate which motor is what. So it just helps you visualize when you are modifying the code for which directions you want the motors to spin. So this circuit is there's a lot of wires, but it's really not too complicated. A lot of it's copy and paste actually. So I'll start here with the battery. It's controlled directly with a switch on the output, and then the output of the battery is connected to directly to the 12 volt inputs of the two L298s, and then it is also connected to a 5 volt voltage regulator. So that 5 volt voltage regulator powers the ESP32cam, the Arduino Due, and powers the encoders on all of the 12 volt geared motors you can see over here. So I guess I'll talk about some of the pin connections. So pin 2 to 5, these are PWM pins. So they control the enable A and enable B pins on the L298H bridges. So they are responsible for controlling the speed that the motor is running at. And it does that by adjusting a PWM value, obviously. This IO1 pin is connected to pin 15, which is the receive 3 for serial. So that's just how it sends commands from the ESP32cam to the Arduino Due. And then over here we have pins 24 to 31. So these pins are used for the L298H bridges to determine the direction that the motor is spinning. So I'll let you look online how the L298 works, but it's pretty straightforward. But it's basically just pin 1 will go high, pin 2 will go low, and then the motor will spin in a specific direction. And then the other pin connections are pins 40 to 47. So these are just the phase A and phase B of the encoders for each motor. So these are the pins that the interrupts are attached to. So I believe it's 40 to 46 is the interrupt pins, and these are how the speed is read from each motor based off the encoder. So this is the bill of materials for the Augerbot. It's not inclusive bill of materials because there's some things that I wouldn't really know how to include them. Like for example, the 3x1 piece of wood, or the rubber bands that I used for the drive belts, which was actually just a section of cut off inner tube from a bicycle. So, but these are all the things that I purchased for the project, and that you could purchase. So obviously the Arduino Due for the PID motor controller, the ESP32cam for the camera stream and Wi-Fi controller, 2 L298H bridges, so those ones are dual channel, so you need 2 of them, one for each set of motors. Obviously the motors themselves, 4 of those, a switch to turn the device on and off, breadboard jumpers. Those are very useful for connecting things together, especially with all the breadboard pins, headers on the microcontrollers and the L298s. There's also 10mm aluminum rods that you need for the axles of the augers. 10mm ball bearings, so that's to rotate the augers with low friction. You also need 5/8 diameter screws. I'm not sure if that's actually right. I don't know if they're 5/8, but I have a link here, and those are the ones that I used. I also bought 3 18650 batteries for the 12.6 volt battery pack. There's also a 3 battery holder, so that's for the 3 18650s, and it puts them in series for the 12.6 volts. And the LM2596 voltage regulator, that's just for regulating the 5 volts for the microcontrollers and the L298s. So this is MIT App Inventor. So this is like a web tool that I use to create the Android controller app for the Augerbot. So it's a really useful website, and it allows you to create a visual interface, which obviously I did here, with buttons and all sorts of different kind of controls. So you can see here's the main screen, and over here is the blocks. So the way you create code in this is like through a visual scripting thing, and I'll just briefly explain how it works.
And so that way, if you wanted to modify it yourself, you would be able to. So what you would want to do is take the existing project and import it. So I'll provide the project file, and that way you can, edit it to your heart's content. So you can see here, here's the layout of the controls. So each one of these is binded to a button, like any of these blocks right here. So if we look out here, it's like, here's forward, stop, reverse. And if we look over here, forward, stop, reverse. So it's all laid out in the same way, so it's really easy to edit what's going on. So if we look a bit closer, you can see every time a button is clicked, send a UDP packet through whatever network you're already connected to. So it will send it to the IP address that's specified with the remote port. That's always the same, but you can change that to something else, but you have to change it on the receiving end. And then the important part is the message sent. So right now it just sends a arbitrary letter uh, that corresponds to a command in the ESP32. So these letters don't have really any meaning. You just want to make sure you have a different letter for each command, obviously, so that way, it can tell the commands apart. The motor speed here, instead of sending a letter, it sends a number from 1 to 9, and it gets the thumb position from this slider right here. So then that way, whenever you move the slider, it will send a new motor speed and it will adjust accordingly. And right here is the refresh stream button, and it will just reconnect to the web address to watch the ESP32 camera stream. Oh, didn't mean to do that. And if we go up here, these two blocks of code, they look pretty confusing, but all they do is allow you to adjust the width of the web viewer. So that way you can adjust the ESP32 camera stream just in case it's cut off. Because I find sometimes it is cut off and it won't let you scale it unless you manually change it. But that's an easy solution to make sure you can see the whole camera. And then these blocks over here are just for changing the button colors when they're clicked, so they're not really that important. So yeah, that's a quick overview on how to use, or I guess the MIT App Inventor project. So this is the ESP32 code in the Arduino IDE. So this code has quite a few functions. So number one, it acts as a receiver from the control Android app for commands. Number two, it runs the camera server, so you can view the stream from the ESP32 cam. And then number three, it decodes the commands that are received and then sends them over serial to the Arduino Due. So it's kind of like a middleman for all the controls. So I'll just briefly go over the code. So we got some global variables here. This one's important right here, the motor direction array. So as you can see here, here is an element for each motor. So there's 4 motors, there's 4 elements. And essentially what it does is it tells the motor what direction and what speed to go. So just by default, it's 1. So that means set the motor speed to 1, which is normalized from 1 to 9 because the speed received can be either 1, 2, 3, 4, 5, 6, 7, 8, 9. And then also the direction. So like the direction will be dependent on whether or not there's a negative sign or not a negative sign. So the code basically takes the command, it updates the negative signs, and then sets the element from 1 to 9 based on the speed that is received. So here's the network setup section. You can set your Wi-Fi access point name and password. I do recommend putting a password, but if you don't want one, you can just delete this line. Right here is the setup. So this is mostly just setting up the ESP32 cam network, and then also setting up the camera server on core 1 for the ESP32 cam. So that leaves us free to use core 0 to run all the code for reading commands and sending commands. So you can see here, basically what happens is it's looking for a packet, a UDP packet, which is sent from that controller app. And if one is sent or received, then it will perform actions based on that. So right here, this block right here is only perform these actions if the command is received. So if it receives an F, for example, it will toggle the LED flashlight on the ESP32 cam on or off. and it will also update the motor speed. So if we go to the Augerbot functions over here, the motor speed, so it's basically looking at the first element of the packet, and if it's a number from 1 to 9, it will update the motor speed accordingly. So 1 being the lowest, 9 being the highest. It doesn't know anything about the actual speed. It just basically sends it a int value from 1 to 9, and then the Arduino Due will deal with that and scale the speed accordingly based on the motor parameters. Then there's also update the motor direction. So that happens in this block right here where functions will be performed repeatedly. So it'll constantly loop through this even if there's no UDP packet received. So if we go here to the update motor speed, so if it comes back to this motor direction array. So as you can see here, it shows that motor 1, motor 2, motor 3, motor 4. So it's kind of like, oh yeah, this is the front of the Augerbot. So this is motor 1, motor 2, and motor 3, motor 4. And it will also update the directions of the array elements so if it's positive 1, it's right. If it's negative 1, it's left. So you can see here, if we're going forward, it will update all the motor directions accordingly. And it will also update the old speed, so that way it will know that if the speed has changed or not. So that's pretty simple right there. And then the last thing to talk about is the send serial command. So this will send the motor direction array over serial to the Arduino Due. So you can see here in this function right here. So what it does, it appends a D to the front of the array. So it converts the array to a string. And it appends the D because it's just some arbitrary character so that it knows that it's the start of the array. So when the Arduino Due goes to read serial, it's like, okay, here's a D. So that means everything that comes after it is directions for how to control the motors. So what it does, it takes the direction array that's filled with 1s, and it will multiply it by the DC motor speed, which is normalized from 1 to 9. So then your array can be filled with values from either 1 to 9, with negative signs or not negative signs. And then basically just checks, is the command that's about to be sent different than the last one? If so, then send it. If not, then don't send it, because there's no reason to spam the same command over and over again over serial, because there's more chance for something to go wrong if you do that. So yeah, that's the basic overview of the ESP32 code. So this is the code for the Arduino Due. Essentially what it does, it reads the serial command from the ESP32, it decodes it, and then updates the PID controllers for the target speed for each motor. So there's 4 motors, so 4 PID controllers. Also, I'd like to say thanks to Curios on YouTube for providing a great video on how to use multiple PID controllers on a Arduino system. It was a great video. So I used some of the code here from their video. So the first thing you'll see here is a simple PID controller class. So this is just how you initiate a PID controller in the code. So I won't really go through that. Right here is pretty important. So N motors. So you have to define 4 motors, or like however many motors for your project. But in this case, for the Augerbot, obviously it's 4 motors. Here's the pin assignments. So this is for the encoder phase A, encoder phase B, the PWM for controlling the H bridges, and the in 1 and 2 for controlling the direction of the motors. Right here is just some PID stuff. Right here is a port and a VT, so this is your target velocity. So by default it's set to 0, but your max would be 300, at least for the motors that I was using. And that way, that's how the PID controller works. You set a target and it will try to adjust accordingly. This function is pretty important. So this is the decode serial command. So it essentially just takes the serial input, breaks it down into the 4 elements that are sent, and then adjusts the speed accordingly. So for example, you got an array of 9, 9, 9, 9. So 4 9s. So it's saying set all motors to, direction left, and set it to this speed 9, which would be max because the speed is mapped from 1 to 9. So here's the setup. Pretty simple. So first you set up your PID controller for each motor. So it does it 4 times, and then it enables the interrupts, which are used for reading the encoder position. Okay, and so this is the loop here. So essentially what it does, it says, is there serial 3 available? If there is, read the command. If not, then continue on like normal. And also, an important note is if it's trying to read serial, you need to disable all your interrupts. Otherwise, you can't read serial. It just simply won't work. And the fact that PID controller for DC motors needs interrupts for reading the encoder positions, that's going to conflict. So what it does here, it disables interrupts, reads the serial, and then enables them again. Then it will decode the serial command and then set the velocity targets. And some more PID stuff right here. More PID stuff. It also has a filter built in, which is smooths the output from the encoders. And then once you have your all your values to evaluate your PID, then it sets the direction and the power for, or not the power, the speed for each motor, and obviously does that 4 times for each motor. And then here just below is the enable interrupts function. So this is just like enabling all the encoder interrupts, and then this is just disabling them. Also below is to set the motor speed, so that it will set the motor speed based on your direction and speed value. And then down here is the read encoder coder template function. So this will create a function for each interrupt, so 4 in total, and that way it will be able to read the position and update the measured velocity accordingly. So that's a really, really quick overview of how the PID controller works for the Arduino Due.
All right, so I'm just going to give my final conclusion and thoughts. So overall, I would say the project was a success. The biggest issues I have are the fact that the motors, they could definitely be sized quite a bit bigger so they could provide more power and torque. And the forward and reverse on the augers didn't work as well as I'd like in either loose soil or grass. The augers move much better when they're strafing left to right or rotating in place. But I would like to test it in snow, which I think it would perform much better in, and the forward and reverse would become much more useful, or at least be able to dig into the snow properly. Some upgrades I would like to make is I would definitely like to make it much lighter because right now it's quite heavy. Um, it would be cool if I could make it light enough so that way it could actually float on water, because obviously the augers are made of plastic and they're mostly hollow. So if you have enough buoyancy, you can float across water, and that's a whole nother dimension or terrain that it can cross. Another thing too, I would, instead of using uh, just rubber bands for the drive belts, I would definitely want rubber toothed belts. And I would also have to reprint the augers and redesign them, and the pulley wheels so that they would have slots for a tooth belt too. That way it could get a lot more traction, and that way the belts wouldn't slip, uh, as because there would be teeth. But yeah, overall, I would say it was a success, and I learned a lot from building it. And I may build a version 3 in the future, but yeah, I have some other projects on the go right now, so that won't be for a while. Anyway, thanks for watching the video, and I really appreciate it, considering that you watched right to the end, and it's a long video.